This video presentation is the second part of a 5-part series on the binomial distribution. So that's example number 2. It says here, a binomial distribution x, a random variable x, right? Or x is a random variable such that x approximates a binomial distribution with a sample size of n and a probability of success p. So given that the mean of the distribution is 4.07 and the probability of success is 0.37, find the value of n, that's the sample size, the variance of x, and C now says to solve for n, whereby the probability that x is at least 1 is greater than 0.99. So let's start with A. We are told that the mean is 4.07. So according to unit 4, by the way, that's from an example of assignment 4. We did a previous video on an example for number 1. So I would say it's a 5-part series. So we're exemplifying each of these 5 questions in this assignment 4, which is based on unit 4. And in unit 4 now, we can see that the formula for mean for a binomial distribution is n times p. Very simple formula, the product of n and p. So therefore now, we simply create a formula with n using the information that is provided. So the mean is 4.07. So therefore, 4.07 must be equal to 0.37 times n. So we can just simply divide by 0.37 on both sides to solve for n. So to cancel out 0.37, we divide the right side by 0.37, and we repeat the same for the left side. So therefore, n is equal to 4.07 divided by 0.37. We can do this in our calculator, and that will give us an n of 11. So n is equal to 11. Find the variance of x, part B. Here we go to the unit 4, and we can see that the variance, which is symbolized by sigma squared, is equal to np times 1 minus p. Now, np is the mean, so we know that to be 4.07 already. And p is 0.37. Okay, so we can simply substitute into this formula. Variance of x is equal to 4.07, that's np, times, open bracket, 1 subtract 0.37. So here we basically type this into our calculator or online scientific calculator, that is 4.07 times 1 minus 0.37, open close bracket, and this will give us a value of 2.5641. But C now says, solve for n whereby p of x greater than or equal to 1 must be greater than 0.99. So we have to solve for n. Okay, so let's isolate this question to get more space. We have to solve for n on the other condition that the probability of x is greater than or equal to 1 is greater than 0.99. So let us focus on the left side of this inequality, this inequation. The p of x is greater than or equal to 1 can be written or can be calculated by saying 1 minus p of x less than 1. So p of x greater than or equal to 1 is the same as 1 minus p of x less than 1 because we do not know what n is. And whatever n is, the probability of x greater than or equal to 1 is a lengthy process because you've got to apply the binomial distribution formula for 1, for 2, for 3, for 4, 5, right up to where n, whatever n is. That's a long process. Now we know the sum of the probabilities of any probabilistic experiment is equal to 1. The sum cannot exceed 1. So instead of going from 1 right up to n, you can simplify the less than 1 and subtract it from 1. Now less than 1 is 0 because this is a discrete variable, random variable. So less than 1 is 0 and these values for x cannot be negative. Minimum value is 0. So therefore now, less than 1 in turn is the same as p of x equals 0. So therefore, p of x greater than or equal to 1 is the same as 1 minus p of x equals 0. Now we can apply the formula for p of x equals 0. R would be 0. N will remain n because that's what we are solving for. So p of x equals 0 is n combination 0. Okay, times the probability of success. We said it's 0.37, right? So that's 0.37 raised to 0 times 1 minus 0.37. So that will be 0.63. 1 subtract 0.37 is equal to 0.63. So that will be 0.63 raised now to the n minus 0, which is n, greater than 0.99. So now we have an inequation with n in it. Now we've got to simplify further. N combination 0 is 1. Any value combination 0 is 1. There's only one way to select nothing from a set. And any value raised to the 0 is 1. 0.37 raised to the 1. So therefore, this is 1 times 1. So this simplifies to 1. So that entire expression here simplifies, or term simplifies to 0.63 raised to the n. So the left side simplifies to 1 minus 0.63 raised to the n. So a simple little bit of algebra. We're going to cancel out from the left side negative 0.63n by adding 0.63n on both sides, and we're going to cancel out 0.99 by subtracting 0.99 on both sides. So then we are left with 1 minus 0.99 is greater than 0.63 raised to the n. 1 minus 0.99, that's 0.01, greater than 0.63 raised to the n. Now, to solve for n, which is an exponent here, we apply logarithms on both sides of the equation. Log to base to any base, so we can also use log to base 10, or we can use log to base e natural logarithms. We get the same answer. And the reason for that is to apply the property of logarithms, whereby the right side of this inequation can be rewritten with n multiplying to log 0.63. Now we're going to divide by log of 0.63. Log of 0.63 is a negative value. And anytime you are dividing or multiplying by a negative value, the inequation must switch direction. So here we're going to divide by log 0.63 on the right, divided by log of 0.63 on the right, means that we've got to divide by log of 0.63 on the left. This division will cause the inequality sign to change direction. And we can leave it there still and then do the switching in the next step. So now the division has taken place. So we switch the direction of inequality sign, as you can see. And we find what is log of 0.01 divided by log of 0.63. So n has to be greater than this number. Go to our scientific calculator. We find what is log of 0.01 divided by close bracket. We have to close the bracket and then divide by log of 0.63. So n has to be greater than 9.97. So therefore n must be equal to 10. Because normally this question asking us for the least value of n. It was not specified, but that's what it's normally asked for the least value of n. N must be equal to 10.